Hello, welcome back to Cracking the Cryptic post-Christmas. We are still solving puzzles every day, and the puzzle on the screen is numbers 482. I presume we say numbers 482 for this. It's by Star Origami, so I'm being brave taking this on in a kind of post-festive food coma kind of way, but I'm going to give it a go and see how we do. So don't forget, on Patreon there's coming up on the 1st of January Blobs' brilliant Lord of the Rings Part 2, much awaited, and it will be fantastic. And of course our apps have been updated. There's Fog of War updates, Line Sudoku updates, and a couple of holiday puzzles in case you haven't seen them already. Check those out on the apps. Now, there's also SVEN'S SUDOKU PAD merch, like my sweatshirt, hoodie. Check it out on the links under the video. But the first link is to numbers 482, I think it is, by Star Origami. Normal Sudoku rules apply. 1 to 9 will go in every row, every column, and every 3x3 box. Good. Within a cage, digits may not repeat, and the sum of their values is equal to the expression in the top left corner. So as you can see, all of these expressions are formed from the digits 4, 8, and 2, and one or more mathematical operators. Okay, here we go. There are 9 vampire cells and 9 prey cells in the grid. One of each in every row, column, and box. One of each. Every digit from 1 to 9 appears exactly once in a vampire cell and exactly once in a prey cell. Digits in vampire cells steal the value of the digit in the prey cell in the same box and add it to their own, in the same 3x3 box. So if you had a 6 here that was a vampire cell, and a 3 here that was a prey cell, the value of this vampire cell would be 6 plus 3, 9, and the value of the prey cell would be 0. That's what I think this is saying. I have done a puzzle with vampire cells before. I think Simon's done one as well. I didn't actually get to the rule where it said that, but I had read it. The value of the digits in a prey cell is 0. So the vampire is kind of sucking the lifeblood out of the prey cell, and it's doing it from the prey cell in the same box. Wow, I mean, okay, there we go. That's a rule set to contend with, isn't it? Give it a try. I don't know. This could take a long time. But let's say the immortal words, let's get cracking. Okay. Oh, my goodness. Look at these numbers. At least the maths is easy. 48 plus 2 is 50. So, shock horror, there's a vampire cell in this group of cells. We know, I hope you know, that the secret remains true, that the value of all the digits, not values, but the total of all the digits in a row or column is equal to 45, or box. And this is going to be important somehow. Well, regularly, I imagine. But the value of those things is not necessarily going to be the same. Okay, here's something. This cell has a value of 4 minus what is effectively 4, 8 divided by 2. This cell has a value of 0, and it is therefore a prey cell. I'm pretty sure that deduction is valid. This one, this cage, has a value of 14, 4 plus 8 plus 2. I bet you Star Origami has rather brilliantly made all of these have different values, these cages. That's very clever, by the way. Just neatness. Okay, I don't know what this means. Also, the fact that this is 50, not 45, but it's for 8 cells, I think that is suggesting that the digit in the vampire cell, no, the digit in the prey cell, not in this column, but in the box where the vampire cell is taking the value, is at least 6. Because the maximum value of the digits in an 8-cell cage is 44. But we've got to get up to 50, so we've got to add a value of 6, at least. I don't know what to do with that information. Maybe I've got to just look at all the cages. So let's go round the board. That one was 14. That's perfectly doable without a vampire cell. Which is a shame, because when I've actually learned something about vampire and prey in this box, you'd want to use it. 4 times 10, 40 in that cage. So there must be a vampire cell in it. Okay. Because the maximum value of 9 ordinary digits, of 6 ordinary digits is 39. And this cage has a value of 40. So there is a vampire cell in it. And these two see both a vampire cell somewhere here in the box and a prey cell in the cage. In the row is what I mean. And they are none. So I'm going to try and use red for vampire, yellow for prey, and green for nothing. So I did learn something there. Now let's... Actually, hang on. There may be more from this. We've got to get to 40, adding the value of the prey cell. Now, if the prey cell was in this 6-cell cage, that would have a value of 0, and the digit in that prey cell would just itself be added to the vampire cell's value. And you'd effectively, therefore, have 6 digits added together. So I don't think the prey cell can be in this cage. I think the prey cell has to be here. Which is really interesting. Okay, I think that's right. Actually, I think we could go further. If we add all of those together, aren't we coming to 40? Because the vampire cell, which is in this cage, is going to take that value. And all the other values within this region are being counted. So I think those 7 cells add up to 40, and these 2 add up to 5. What do you think of that? I think that's right, but this is doing my head in. And I was planning to go around the whole grid. So this is, okay, 12 divided by 2, 6. So that could obviously be a vampire or a green ordinary cell. This one, this is massive. This is the starting point that I hadn't seen. 32 divided by 2 is 16. That is a vampire, and it is adding 9 and 7. So either this is a vampire cell with a 9 in and the prey cell in the box is a 7, or this is a vampire cell with a 7 in and the prey cell in the box is a 9. Now, those cells see a vampire and a prey cell. They go green. Right, just before I get on with the rest of the thinking around that, let's have a look at, there's still 5 other cages to look at. This one is 4 times 6. 24. Well, we know it doesn't have a vampire cell in, and I think I could have deduced that. It must have a prey cell in, because the minimum value of 7 cells is the triangular number for 7, which is 28. So the digits in here would add up to 28 minimum, and we can then remove the digits that add up to the vampire cell in the box where the prey cell appears. No, well, yeah, we can remove the digits in the prey cell that appears in this row. And we're still getting to 24. So that is 6 quite low digits and another one in a prey cell. This is now not prey or vampire. Now, this is a 9-cell cage. Oh, this is going to be huge. The 9-cell cage, we weren't told how many vampire and prey cells can be in it. We were told that every digit has to be in it because there's no repeated digits in a cage. So the digits in this obviously add up to 45. Now the total of the cage is only 12 times 2, 24. There have to be prey cells to the value of at least 45 minus 24. I think that's right. There have to be prey cells to the value of 21. There have to be 3 prey cells in here because we've only got 3 rows and columns to play with. Now, a maximum 1 of those can be in this box, and is. So there's one prey cell in box 1 in this cage. We've got to get 2 more prey cells into it. We can't put a prey cell here, or that would rule prey cells out of those, because there's only one prey cell in each row and column. And then we would only be fitting 2 in. So this is not the prey cell. There is one in box 2, and there is one in box 4. So, I mean, my marking is not very helpful. And those prey cells add up to at least 21 between them. That's weird. I'm not ruling out that there's a vampire cell in the cage, but it's getting less likely with the totals that we have to achieve. In fact, if there was a vampire cell in the cage, it can't be in the boxes where these prey cells in the cage appear, because that vampire cell would suck that prey cell value and effectively mean you were just adding up 2 what I'm saying is, if those 2, for instance, were a prey cell and a vampire cell with a 7, let's just say a 7 in the vampire and a 3 in the prey, they would still be worth 10 together. It doesn't change anything from if they weren't prey or vampire. So if there is a vampire cell in this cage, it's here. I don't know, it's not impossible. Right, let's just look at the other cages before I carry on. 10 here, that could be done with green cells. What's this? 34. Okay, I'm going to come back to that in a moment. Let's just look at this. 32 minus 2 is 30. Now, in 4 cells, that could be done with green cells and would be quite helpful. But it could have vampire, it could have vampire cells in it. Maybe it could have, it can't have prey cells, because the 3 prey cells for rows 2, 3, and 4 are there. Okay, this one, 34. Yes, okay, this has got, I can't believe it, this has got 2 vampire cells in it. 9 and 8 and 7 are the values of the digits that you could put in maximum, 24. You still need to add another 10. You can't do that with 1 vampire cell adding a maximum 9. You've got to have 2 vampire cells. This can't be a vampire cell because it would stop both of those being a vampire cell by the only 1 per row or column rule. So those 2 are both vampire cells. Now, can do a little bit of greening in that column. And these 3 see a yellow and a red. And actually, this must see a yellow up there, so that goes green. These 3 all see a yellow in their column because there are 3 yellows in this bunch. They clearly all see red. These 3 see a yellow in their row. Ah, okay, so now this cage, what is it, 30? That is 9, 8, 7, 6. It's all green. This one is 10. That is 1, 2, 3, 4. It's all green. I mean, that's fascinating. Okay, good. This is a real start now. I'm feeling good now. Now, there's more. These 3 see a red in the box and a yellow in the row. These see a red in the row and a yellow in the box. Both of these see a red in the column and a yellow in the box. This must be the red vampire here. Okay, now there is a red vampire in this 14 cage by Sudoku. Those have gone green. These go green. That's got to be yellow. That's a prey cell. Wow, and there's a prey cell in one of these 2 in column 6. These are green. In fact, all of these are green, because these see a yellow in their box and a red in the corner in the row. These see a yellow in their box and a red. This is the yellow in row 1. Now this box and this column have got their red and yellow. Wow, you get to colour a lot of the grid in this scheme. That is green because it has red in the row and yellow in the column, and that one too is exactly the same. So the yellow in row 6 is in one of those 2. Yeah, yellow, there's still a yellow. Okay. Haha! Well, this has all been done without real numbers. This is brilliant. Okay, so it's going to get harder when I have to think about numbers. I mean, I'm not saying this hasn't been hard so far, to be honest. I'm quite pleased with how it's gone. How could this be a prey cell and have a value of 0? These would have to have a value of 34. It's just possible. That's extraordinary. I bet they do. Okay, they could, because in each box, they could be, in one case, a 9 in the vampire cell and an 8 in the prey cell, giving a value of 17. And in the other, an 8 in the vampire cell and a 9 in the prey cell, giving another value of 17, and that would make the 34 necessary. And that could be green. Which is, no, that could be yellow in that case. That's what I mean, sorry. And that is still possible. That would leave this to be a red of 7 with a yellow of 9. Oh, hang on. That's value is 0. The value of these, oh, that is the 7 or 9. That's what we worked out was going on in this box. Yes. So the value of these is 24. That is the cage total. Plus that, I'm adding digits now, not values. Doesn't really matter. It's the same. Is 40, and that is a 5. There's my first digit after 13 minutes. Because this row has to add up to 45, both in values and because, yes, because the red and yellow are in the same box, it is 45 both in values and in digits. Now this digit is not 7 or 9 in this box, it's 6 or 8. This one is green, that is a 6, a natural 6 to give its total. And now this is an 8. This is not 6 or 8, this is not 8. In fact, this is not 8, it's in the same box, same cage as an 8. Suddenly multiplied by digits achieved up to 3. Now, is this worth thinking about? The 3 digits in the yellow cells here, I said had to add to at least 21. And I'm standing by that. I think that's true. What does that mean? I don't know what it means. It means they're at least 4, 8, 9. No, hang on. That one is 9 or 7 already. Yeah, okay, they could still be 4, 8, 9. The pressure will be eased on those reds to have a huge digit if that one... I know they don't... They do need to be quite big in this cage because they have to be contributing their own value to a total of 34. What was it? 34, it is 34, yeah. These 3 cells add up to 14 together because the vampire cell here is taking that value in as well. So the digits here add up to 14. I don't know there. As soon as I've made these add up to 5, they can be anything they want. Oh, this is so confusing. Right, if that was 9 adding a value of 8, that would be over here. If that was 8 adding a value of 9, that would be a 9. I can't see the problem with that. I bet that is going to happen. I still think this is going to end up being yellow, but it feels like that's a really weird way for it to go. But okay, hang on. How many reds have I still got to find? I've got to find 4. And they're in boxes 1, 2, 4 and 5. Only, whoa, no, is it true only one of them can be in this cage? No, that's not true at all. Maybe it's become true because of the value. I don't know how to work that out. I'd rather do something else. I don't know what else to do. Okay, what are the minimum values of red cells? What is going on here with the minimum values? Let's say that this could be a 9. Then these have to have a value of 25 minimum. And that means that, well, it means they're adding prey cells with a value of at least 8. That's not as oh no, hang on, if that was a 9, these would be 7 and 8. They'd be adding prey cells with a value of at least 10. But I don't know much about the other prey cells. Well, okay, I do. I know that that is 7 or 9. I know that the prey cells here add up to at least 21. Oh, with that, they add up to at least 28. Well, at least 28, those 4. And the 2 that these are adding up, which are here and somewhere here, have to add up to at least 10. Well, that gets us up to 38 minimum for 6 cells. The maximum for 6 cells, they all have to be different, is 39. And that means that amongst these yellow cells in cages, we have not used 1 and 2. I'm missing one. No, I'm not. That is 6. Yeah, in fact, the yellow cells in these cages, in these boxes I mean, have to be from 1, 2, 3 and 4. Because to get up to this value of 38, I'll take you through again how I've calculated the value of 38. I've calculated that we need the yellow cells in this cage to add up to at least 21. Plus at least 7 there is 28. Plus the values that these 2 reds are going to take have to be at least 10 there and there. That's 38 in 6 yellow cells that are either 987654 39 or 987653 38. So the remaining cells are either 124 or 123, and they are going in these places and one of these 2. Now, can I say that that is not here now? Not quite. If there was a green 1, no, sorry, if this was a yellow cell, oh, these would add up to 17. They would be 8 and 9. That would be 7. And the most these could be is 6, 5 and 4. That's not enough. Right. That is not a yellow cell now. That is green. That is yellow. Sorry, that's been clear for a while. And this is from either 1 or 2 and 3 or 4. So that is a low digit. Now, these 2 have to add up to at least 10. The yellow cells here. And the yellow cells here are at least 21. This has to be a 7. Otherwise we're busting the total. We would have 30, 40 in 6 cells of yellow. So, now we can't have a red 9. Is that interesting? No. I bet we have to have a 9. So, we had to keep the value down. We've already got 21, 28 amongst 4 cells. 9874 say that the value of the 2 yellows that are getting added into this cage is maximum 11. So this cage its digits add up to 23 or 24. It's either 986 or 987. Where are we going to put a 9? Not in a red cell because we've had a red 9, so there. Where are we going to put an 8? Not there because there's an 8 in the column. There. This one is 6 or 7. Wow, I mean, this is doable, but it's completely confusing. Now that 9 is going to sort out this cage fully, which is nice. Bit of Sudoku. Never object to that in a Sudoku puzzle. That can't be an 8 because it's red, and we've had a red 8. So there's an 8 in one of those 2 cells. And an 8 in one of those 3. I mean, these are getting a bit constrained in terms of the high digits that must be making up the sum of 21, but that row is quite unconstrained. This row, I suppose well, imagine you had a 5 here and an 8 in the yellow here. Then you could have a 9 here and get to 22. Oh my goodness. First of all, that cell sees red and yellow. One in the box, one in the row. So that's green. This is the only remaining possible yellow cell in row 6. So that plus that equal 10 or 11. Great finding, Mark. But it's true, and it's worth bearing in mind. Now, the O that I gave out a moment ago, I was thinking about this the wrong way. Earlier I did note that this area was going to contain 4 more red digits. And I was wondering how many could be in the cage. We are now very constrained on the cage, by the way. Yes. Yes. Oh, this is madness. Okay. What I was wondering was how many could you put in the cage? What I should have been wondering is how many reds can you avoid putting in the cage? We've got to get 4 reds into this whole area, remember. Try putting none in the cage and see where that gets you. You can have 1 in that group, 1 in that group, and 1 in that group. You can't have any more around the perimeter of the cage, around its outside. There's a maximum 3 cells, so there is a red cell in the cage. Earlier I worked out that had to be here. I just want to think that through again. We need to deduct from the value of digits in this cage the 3 yellow cells, and we don't need to be adding them back in. Yes, that is right. So that red cell, which I've now worked out there must be 1 in the cage, is not in any of those boxes. It's here. This is a red cell, and it can't add more than a value of 1 from its prey cell, and that is getting the 1 from box 5. There we go. We are really in business now. Now, this is all maxed out. The value of these, it doesn't actually matter what digit goes there. It's really weird. This puzzle seems to matter much more what goes in the prey cells than what goes in the vampire cells. But the vampire cells are always turning up in cages. Well, actually, that is being snapped because the vampire cell in box 2 is in one of those. I don't know where the vampire cell in row thingy is. And there's no more in the cage. Right, so there's a vampire cell there. That's not a vampire cell. These 2 are green. Anyway, we've got 21 in the yellow cells in the cage, which is either 984. That's exactly what it is, isn't it? 9, 6 doesn't get there. We need another 6. 8, 6 doesn't get there. 984 are the vampire cells in this cage. That's a 7. We've had a 1. These are a 2, 3 pair. These are a 5, 6 pair that add up to 11. That's what we needed. And the 6 there tells us which way round they go. Yes. Okay. Now that is 2 or 3. This pair had to add up to 5, so they can't have a 2 or a 3, and that's beautiful. That's a 1, 4 pair. These 3 we're going to add up to 14. And we could do that by having them be 2, 3, 9, 2, 5, 7, 3, 5, 6. There's basically lots of ways. Oh, 6 by Sudoku in box 9. It's ruled out of those. It's in the red cell. which doesn't really, oh, well, that doesn't really matter here. It does matter here. This is a 7. Actually, I could have worked that out by adding up the values. 24. Oh, hang on. This has added up to the wrong thing. Oh, no. This has added up to 35. Oh, this is not a 7. Why have I written 7 in there? What was I doing? I was fine up to here. Then I wrote 7 in here because we've had a red 6. That's valid. Oh no, but this can't be a 7. This cage will add up to 24 plus 11 is 35. Oh, Mark. You can't put another 6 in red. Was this 6 wrong? What's gone on? I was so solid. I was so certain this was going well. Please just have made a very recent error, Mark. Come on, think it through. Wanted 984. No, that's what I did wrong. Got it. I've thought it through and I've worked out what I did wrong. Right, after I worked out, it's okay, this is going to go quickly. After I worked out that this had to be red, that was valid. But because that is adding a value of 1, now 21 is not enough to deduct from the yellows. It has to be 22 because we added 1 into this cage from there. There we go. So it's 9, 8 and 5, which are the yellow digits here. 9, 8, 5, 7, 1. These have to add to 10 or 11. It's now 6, 4 maximum. So that is a 4 and a 6 like that. Now 4 is a better digit here, I think, for us. I don't know. Anyway. Ah, yes, this is the point. 4 and 6 there. 10. These now add to 24, and that is a 7. Now I can do the Sudoku on 6s and put a 6 in there. Now I know I've had 1 and 4 in yellow. That's a 2, 3 pair. This is a 1, 4 pair again. We're okay, I'm back on track. And I don't care if you think, what an idiot. I'm struggling through this and I'm happy. 6 there, you can't stop me being happy. There's a 9 in one of those cells by Sudoku. These add up to 14 by the rules. Now, we've got red there. I can go back to red in one of those two, red in one of those two, and red in one of those two. Those are green. These are all green. Trees are green. 1, 4, 6, 2, 3. Yes, 9, 8, and 5 are the digits that are getting zapped, prayed out of these cells. That, it doesn't matter what it is. Well, I'll tell you what does matter. It's not 9, 8, or 5 because they appear in yellow cells. So that is 2, 3, 4, or 7. But it's in a red cell and it can't be 7. In fact, what have we had in the red cells? 9, 7, 8, 6. Remaining red cells are 1, 2, 3, 4, 5. That one's not a 5. This one's not 1 or 4 by Sudoku. That one's not 1. Those aren't 1. 1 is in one of those pairs. One of those pairs has a red 1. Let's go back to this. We've got 9, 8, 6, 1, 4, 2, 3, 5, 7. Oh, there's a 7 in one of those cells. That's just Sudoku. What about 5? Don't know. These can't have a 4 in. These must have a 4 in. That can't be a 1 by Sudoku. There's a 6 in one of those two by Sudoku. Maybe everything I do from now on is by Sudoku. There's a 7 somewhere up there. Okay, come on. Keep thinking about the red cells, maybe. This is the sort of thing I get tempted to do. 9 is in one of those cells, and I was about to say, oh, 9 can't be in red, so I can put 9 there. But 9 could be in one of these cells and not be red, so I have to be very careful. These are 2, 3, 4, and 5. That top one can't be 5. This one can't be 4 because of the 1, 4 pair. Now, this group of cells, I did look at these earlier. They've got a 6 in now. There's a 6 in there. And they add up to 14 as a group of 3, which is either, well, it's not 6, 2, 6. That's not allowable. So it is 6, 3, 5. And we get a 3 in the corner. Oh, Christmas tree, is it still okay to do that? Oh, Christmas tree, how lovely are your branches. That becomes a 2 because it sees a 5, 6 and a 3. And everything else in the row, oh, that is a 7, 9 pair, naked pair, and that's an 8 in the corner. And we've got the 3 in yellow, so that's the 2 in yellow. And this can't be a 2 by Sudoku, nor can this. 7, 9, 6, 8, 2. These are from 1, 3, 4, 5. I don't care if you think I'm over pencil marking. I'm still happy. Happy Mark solves a Sudoku. Now, we said something about the red in this column, and I think it wasn't a good thing. No, it was all right. What we said in this column was, since the digits, we now know what the digits in this, yes, we know what the digits in this column, in this cage add up to, which is 45 minus 3, 42. But we have to get the values in this cage to add up to 50. And to do that, we have to get the yellow cell that these are adding to be an 8. And that is going to have to be in one of these 2 cells and be a yellow cell. And that's going to stop all of these being yellow and make them green. We've got an 8 as the extra digit there. The other, sorry, is the prey digit there. The other prey digits we need to put in here are 5 and 9. Well, 9 can't go in those, so it's here. And 5 is the prey digit here. Yeah, that is right. I'm confident about that. Didn't tell me about 7, doesn't tell me about the vampire digit here, but that's fine. The prey digits are much easier to find out about. I learned that in this puzzle than the vampire digits. There's a 6 in one of those 2 cells. Now, this cage, remember, it also has to contain all the values, no, all the digits, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these see 6, 7, 8, 9 and 5 in the box. They're from 1, 2, 3, 4. So's that. Can I, oh, 9 there is Sudoku, looking down at the bottom of the grid. There's a 7 in one of those 2 as a result of that. Well, I'm not afraid to pencil mark to death. Here we go, 2 there, and that's not 4. Those are also from 1, 2, 3, 4, 5, because there's a 7 definitely down here. I feel like I might suddenly pick up a triple or a quintuple somewhere. Though that can't be 5. Now, that can't be 9. I don't know how long that's been available. That's a 9. It seems like a long time. There's a 9 in one of those 3 cells. 8 is here. Okay. That is 3 or 5. And these are from 3, 5, 7. Now, how are these doing? Fine on their own. Okay, well that was a burst of activity. The 5 in one of those cells says that's not a 5. There's an 8 in one of these. And there's an 8 there, so one of these 2 is an 8. Oh, the red digit. We only have 1, 2, 3, 4, 5 to go in the red digits. One of these 2 in row 2 is red. And that completes the quintuple complement of 1, 2, 3, 4, 5. All of these cells in the rest of the row have to be from 6, 7, 8, 9. But these three are in a cage which already has a 9 in. So they are 6, 7, and 8. Now, can I just write 6 in here? This can't be a 7. Yeah, 7 is in one of those, I don't know. Is there a way that could be an 8 and that be 7 and 6 and that would be... No, this can't be an 8. For some reason I said 8. Yes, one of those is a yellow 8. That's it. So that's a 6. Yes, this is a 7, 8 pair. Let's get rid of the corner marks there. That's not a 6 now. There is a 6 up here though. Okay, that was good. That was useful. That was really interesting as well. Now, okay, in the box, no, we've had 6, 7, 8, 9 in the cage. So these digits are from 1, 2, 3, 4, 5. And they include a yellow 5. And we've got 4 of the 5 low digits in this row. 7 is either going there or there. Okay, what are the high digits that we still have to put in red? We've got a 5 down here because it can't be 6. I hadn't even worked that out before. Then these others are 1, 2, 3, 4. And those ones can't be the 1. So we've got either 2, 3 or 4 as the high digit here. And these have their, sorry, as the vampire digit. And these have their vampire digit as 1, 2, 3 or 4 as well. I don't know what that means. Have I got something going on down this column? Or this column? Where does 8 go? It could go there. Can it possibly go here? Yes, is the boring answer to that. Okay, let's look down this column because I've got 4 digits from 1, 2, 3, 4, 5. Right. I've got a sextuple in this column. Okay, here's the simple question. I was about to show this by pencil marking this with 6 digits. But what I'm going to do instead is say, where does 7, 8 and 9 go in this column? I hope this is helping. Yes, it's going to. Where does 7, 8 and 9 go? There is possible. There is possible. There is possible. The only other apparently possible cell is here. And I'll tell you why that is not 7, 8 or 9. Oh, quite simply, we've put 7 there, 9 there, and pencil marked 8 into here. Yeah. So 7, 8 and 9 are a trio in this column, in those cells. Now, this one cannot be red because we've had 7, 8 and 9 in red. There we go. That's marvellous. I'm very proud of that. That is red. That is not. That is red. And now I can put in some of these numbers. That's the red 5 because we've had the red 6. That's a 6. That's a 6. That's not. We need a 6 at the top. There it is. We've got this 5. That's not a 5. And 5 is going to be yellow here because we needed the yellow 5 to be here. Brilliant. Brilliant. That is now not yellow, nor is that. They're both green. That is definitely yellow, and it needed to be the yellow 8. And we've got all the yellow digits in the grid now. 3, 5, 8, 9, 1, 6, 7, 4, 2. Yes, that's a 7. These are not 8. They are the remainder of our triple, and they are now a 7, 9 pair. The reds, this one is 2, 3 or 4. So is that. Still got reds to sort out. One of these is low, I mean, is red. Obviously one of the, oh, okay. I can't do any more on that. Can I place 9 in box 1? Yes. There, and that cannot be red. So that's green, that's green. These two are red, and they are from our 1, 2, 3, 4 family of reds. Oh man. Okay, so that's not 9. Oh, I didn't mean to get rid of the colour. I meant to get rid of the corner mark. This is weird and tough, isn't it? Oh goodness, I'm so happy that this is going along now. So happy. It's pathetic. It doesn't matter what that is for its cage. It's just taking that value in. Oh, but this is a 1, 2, 3, 4 quad. And of course the reds are a 1, 2, 3, 4 quad. Oh, am I going to be colouring 1s, 2s, 3s and 4s? Right, where's 5? It's in one of those two cells in box 2. That's a 1, 2, 3, 4 quad. Oh, goodness, I can't quite get my handle on this yet. That was picking up an 8. Are there any other values left to work out? I don't think there are. I think I've done all the cages and values and everything. I just need to Sudoku this now. Oh, one of those is a 1. Well, they both see that cell, so that can't be a 1. Can I pull this off somehow? If that was a 2, 3, 4 triple, that couldn't be any of those, but it doesn't have to be. Eight in box 7 is in one of those two cells. I've got to finish off 9s, 8s, 7s and 6s. That's probably what to do next. Oh, 7. No, 7's got all of those possibilities. Oh, come on. How do I finish off 9s, 8s, 7s and 6s when I don't know anything more about them? I mean, I've apart from the red 1, 2, 3, 4, I've filled in all the vampire and prey cells. I don't think I can use those and their values at all anymore. Here's a weird thought. These, oh, that can't be 3. Okay, so because of that, now 3 is in one of these cells and that can't be 3. I mean, big potatoes, what use is that? Okay, the thought I was having was if these didn't include 1, 2, 3 and 4, they would have to be 7 and 8. And then these would include, oh, that can't be 3 by Sudoku now. 3's in one of those cells. Goodness, I can't see how to get this going again. 1. That's a group of 4. So that cell is one of those two. Oh, there's something with just these groups of 1, 2, 3, 4. What am I meant to be doing with them? Ah, right. That digit, where is it in this cage? It's not in those two cells. They're in the same row. And it's not there because that's also red. So that digit, let's give it an orange flash, is also there. So that can't be 3 either. Orange may not have been the best choice, but I have a feeling I'm going to be doing this again. Where is this digit in the cage? Again, it can't be in the other red cell. It can't be in its same column or its same box. So those two are the same. Can I pull that off with this? No, not really. But that is 2, 3 or 4, so that can't be a 1. I mean, this could turn out to be valuable if I can do enough of this colouring. I mean, I did say, looks like I'm going to have to colour the low digits, and now I'm doing that. But at least I have some idea what to do. Now, those are orange and blue. These are whatever the other two colours are. So these are now orange and blue in the same cage of 1, 2, 3, 4. I should get rid of all the green colouring because it's so unnecessary now. I've done all the red and yellow, haven't I? So yeah, somehow just using this as a group of 1, 2, as an extra region of 1, 2, 3, 4 is meant to help, but it feels like a very difficult bit of help, if I'm honest. Still, this is what we've got to do, so we will take it on with a will. Now, we've had an orange and a blue. If I called that green and this one violet, how would we get on with establishing where... Oh, so in this cage, that has to be violet. Yeah, I mean, that's worth something. Then that is violet, because we've got violet there and violet there. I mean, that's something I haven't, so it's not a 2 up here, so I can take 2 out of those cells. I mean, I'll take these tiny little wins all day long. We've had orange, violet, blue, that one's green and is not a 1, therefore. Green, purple. Now, we can't have this. Look, this sees all the 1, 2, 3, 4s. It sees green and violet. It sees blue and orange. So that is an 8. And that's not. And now I found an actual digit with this method, which, you know, cheers me up. These are 1 of each, blue and orange. Green, purple, blue. We need an orange down here somewhere. It can't be there. It's in one of these 2. We've got yellow. Oh no, why is 3 yellow? Because it's a prey cell. Ah, that's interesting. So this is not orange. Yeah, I don't know what colour that is. So forget yellow. I'm only interested in red, yellow, sorry, not red, yellow, in the others, in blue, orange, green, green and violet. So, violet here is not there and is in one of those 2. Have we got, we haven't got where 5 is in this column. Oh, why did it get so complicated at the really back end? That's so mean. Am I just being dumb to find it this hard now? I doubt it. I'm trusting myself, if I'm honest. I'm still happy solving this puzzle. Green is either there or there. In fact, these 2 in this cage are green and violet in some order. Every low digit is something. That is not green or blue. It's either violet or orange. And it's a 1. Which I could have known from here because 1 has been confined to those cells in this region. Green in this box is in one of those 2. Which is a green 5 mix. Oh, green is in one of these 2. And therefore one of these 2. Ah, now we've got some. No, hang on. That was right. No, it wasn't even necessarily right there because green could be a 2. Could have been there. I was ruling it out of there. That was fair enough. But green could be a 2, so I cannot rule it out of there. It's in one of those 3. Ah, goodness. I was just about to say, well, if green has to be there or there, it's a 4. Well, if green is in one of those two, let's say this, then green is in one of those. No. Even that's not solid because this doesn't have to be green. Okay, sorry. I'm getting ahead of myself again because I'm struggling to find an actual way through this. Okay, if this was orange, blue in this box would be there or there, and that would be blue, and that would be blue. If this was orange, it would have to be a 2, because that's the only overlap digit between those. Let's just see what happens to orange if it's a 2. Well, no, if those two, if that is orange, it's a 2. I don't know, ran out of steam quite quickly there. Orange and grey, we've had green. Where's violet in this column? It's in one of those two. Again, along with 5. Wow, I don't know what to do at the moment. Orange and green are there. We still need blue and violet in this row. That is one of them. Because any number from 1, 2, 3, 4 has got a colour. So actually that's a colour. And it's the same as 2, obviously. So it's the same there. Should I have just done more with 2? Generally, 2 has to be in one of those cells. Oh, where's 9 in this box? It's definitely there. Oh, this might all have been a lot easier to get on with. That's made that a 7, and that's a 9, and that's an 8. And that's not a 7. Oh my goodness. This was probably just staring me in the face the whole time. That's a 7. How are we doing on 7s? We've got 2 more in a sort of X-wing, there and there. How are we doing on 9s? I bet they're all done. They are. And 8s? No, they're done in rows 1, 2, 3, 7, 8, 9. That's an 8. Look, I can see that now. And those 2 aren't. And then we've got an 8 X-wing in rows 4 and 5, just like 7s. And 6s, I think we had them all done. Okay. So, has that helped the position? Yes. Yes. Look, that's a 1, 2, 4 triple. That's a 3. And that's a 2. And that's a 4. And that's one of the reds. So 4 comes out of all the other reds. I think I may have overcomplicated things quite dramatically. 4 also comes out of the boxes. And there we go. There's 4 in box 1. And 4 is green. Oh, well, I knew that from here. Those can't have a 4 in. That is 1, 2, or 3. We've got a triple here. So that's 4 or 5. That's 4 or 5. 4s are... Oh, sorry. 4s are green. That is a 1, 4, 5 triple. That's a 3. This is just Sudoku. That's a 5. This one is not 5. These don't have a 3 in. Goodness. Maybe it wasn't that hard at the end. Maybe when I was trusting myself. This seems to be a naked 5. I shouldn't have been trusting myself is what I was going to say. I should have been going, it's not really that hard. That's a 3 by Sudoku. That's a 1, and that's the purple digit. There we go. 1 in those. That's a 2. This is a 1, 4 pair. 1, 4. Okay, the low digit colours, they are not helping. I'm getting rid of them all. Orange, green, purple, and was it violet? No, purple was violet, it was blue. There we go. Bye-bye colours. You weren't doing anything. The rest is Sudoku, as Hamlet so nearly said and wanted to say in Act 5. That's a 2, 3 pair. Now, in fact, we know the order. 2, 3, that's a 4. This is just coming together. Oh, I think it was more straightforward at the end than I realised. That is now a 7-8 pair that's going to get resolved by an 8-3 pair. Oh, it's this cage, isn't it? 2, 3, 2, 1, 2. This is 4 and 7. That 7 does the 8-7. That 8 does the 8-3. And then I've got a 3 to put in. And that is the solution to numbers 482. 57 minutes, not a shock. It's been solved an average of once a day for the last month. It's a very hard puzzle in my opinion. I'm delighted to have got through it. Thank you for watching me do that. And thank you for watching us on the channel. It's just a pleasure to be with you. See you again soon. Bye for now.